Our journey begins in the raw material warehouse, where high-grade carbon steel rolls and bars are meticulously organized under cold, bright industrial fluorescent lights. A factory technician carefully maneuvers a pallet of premium steel toward the quality control zone to ensure every batch meets our rigorous manufacturing standards. We utilize advanced X-ray fluorescence technology, placing the spectrometer directly on the steel surface to verify the precise chemical composition of our raw materials. The digital display confirms the exact ratios of carbon and alloys, ensuring the metal has the necessary properties for a high-performance, durable cutting edge. Precision is paramount from the start. We use high-accuracy digital calipers to measure the cross-section of every bar, recording data to maintain absolute consistency. Every measurement is meticulously logged on our inspection forms, creating a permanent record of quality for this specific batch of high-carbon alloy steel. We separate our high-carbon 1075 and nickel-rich 15N20 steels. These two specific alloys are chosen for their beautiful contrast after the final etching process. With the chemical and physical checks complete, these materials are labeled and approved for transport to the cutting station, ready to become a blade. The manufacturing process intensifies as industrial saws slice through the steel bars, creating uniform plates that will form the foundation of the Damascus billet. As the abrasive disc bites into the metal, a steady stream of sparks signals the successful shaping of our high-quality carbon and nickel steel plates. Safety is our priority. Operators wear full-face protection and specialized gear while overseeing the precision cutting of these hardened alloys for our knife blanks. To ensure perfect bonding, the steel plates are submerged in an ultrasonic cleaner, where an alkaline solution removes every trace of oil and industrial grease. High-frequency vibrations create millions of microscopic bubbles that scrub the steel at a molecular level, leaving the surfaces pristine for the upcoming forge welding step. After the bath, we use pressurized air to flash dry the plates. Any moisture or residue left behind could compromise the integrity of the fused metal. Wearing clean nitrile gloves to prevent skin oils from contaminating the metal, we stack 15 alternating layers of carbon and nickel steel to start the billet. Alignment must be perfect. The technician carefully squares the stack on a precision table, ensuring that each layer sits flush against the others for welding. A heavy-duty C-clamp is used to exert massive pressure on the center of the stack, eliminating any gaps between the plates before they are permanently joined. We use MIG welding to create strong points at each corner. These tack welds hold the 15 layers in a single, solid unit for the furnace. The glowing spot welds quickly cool, locking the billet into place. This stack will eventually be folded until it reaches a staggering 120 layers. The billet is now introduced to the high-frequency induction furnace. This modern technology allows for rapid, uniform heating that is essential for high-quality forge welding. The digital controller monitors the temperature with extreme precision, showing the heat climbing steadily as the steel undergoes a transformation at the molecular level. We reach the critical threshold of 1150 degrees Celsius. This is the exact point where the different steels can begin to fuse together. Inside the coil, the billet glows with a brilliant yellow-orange light. This intense heat makes the metal soft enough for the layers to diffuse into one. Using heavy tongs, the smith retrieves the white-hot billet. Timing is everything here. The metal must be worked while it is at its most malleable state. The glowing metal is placed under a massive 150-ton hydraulic press. The sheer force will squeeze the layers together, initiating the forge weld. As the press descends, the 15 individual layers of steel are crushed together, becoming a single homogeneous block of high-performance Damascus alloy through heat and pressure. Notice the slight bulge at the edges. This physical distortion indicates that the metal is flowing and bonding correctly across the entire surface area of the billet. We rotate the billet and press it along different axes. This multi-directional forging ensures the internal structure is dense and the bond is perfectly uniform throughout. After multiple cycles, the layers are fully integrated. What started as 15 plates is now a single solid rectangular bar, ready for the next critical test. The billet is moved to the anvil for a traditional quality check. The sound of the metal under a hammer tells the smith everything they need to know. The artisan strikes the metal with a heavy hand hammer. They are listening for a clear, ringing tone that confirms a perfect, solid bond between the layers. A dull thud would mean a hidden delamination, but a high-pitched ring indicates success. This sensory check is a vital part of our traditional craftsmanship process. The hot billet is quenched in specialized part 50 oil. This rapid cooling stage is crucial for managing the internal stresses of the newly fused Damascus steel. Flames erupt as the oil ignites, a spectacular but controlled part of the process. This quench locks in the grain structure before the next folding sequence begins. To increase the layer count, we cut the forged billet in half. Each cut and stack doubles the complexity and beauty of the final Damascus pattern. By stacking these halves, we jump from 15 to 30 layers. This repetitive process of forge welding and cutting is the heart of the Damascus technique. The cycle repeats. Another cut, another weld, and we reach 60 layers. Each fold refines the steel, distributing the carbon and nickel more evenly throughout the billet. One final fold brings us to a total of 120 layers. This high count provides the intricate, wavy visual texture that our knives are famous for. The completed billet enters a vacuum furnace. Heat, treating in a vacuum, prevents oxidation, ensuring the steel remains pure and free of surface decarburization during hardening. We seal the chamber tightly. By removing the air, we can control the environment perfectly, allowing the steel to reach its maximum potential for hardness and toughness. The vacuum pumps hum, pulling the pressure down below 0.01 millibars. This near-total vacuum is essential for the advanced heat treatment protocols we follow. The temperature is held at a precise 790 degrees for 45 minutes. This soak time allows the crystalline structure of the steel to fully transform. Immediately after heating, the steel is plunged into liquid nitrogen. This cryogenic treatment is a modern secret to achieving superior edge retention and structural stability. At -196 degrees, the remaining austenite in the steel converts to hard martensite, significantly increasing the knife's overall wear resistance and durability. We verify the results with a Rockwell tester. A reading of 63.5 HRC confirms that our heat treatment was successful and the steel is ready for machining. The hardened billet is now clamped into a 3-axis CNC machine. This transition from traditional forge to modern automation ensures every blade profile is perfectly identical. The milling head follows a programmed CAD path, carving the elegant silhouette of the blade with mathematical precision that no human hand could consistently replicate. High-speed steel chips spiral away as the bit shapes the contour. Even though the steel is extremely hard, our advanced tooling handles the material with ease. A constant stream of specialized coolant prevents the blade from overheating, protecting the temper of the steel and ensuring the cutting tool remains sharp and effective. Next, the rough blank moves to the surface grinder. This machine will flatten the blade and prepare the primary bevels that define the knife's cutting geometry. We use a cubic boron nitride wheel to grind a perfect 15-degree bevel. This specific angle is the gold standard for high-end Japanese-style culinary knives. The technician uses a digital gauge to check the angle. Maintaining exactly 15 degrees on both sides is what gives our knives their legendary, effortless cutting feel. We inspect the edge geometry under a measuring microscope. This allows us to see fine details invisible to the naked eye, ensuring the edge is perfectly centered. The monitor displays a thickness of just 0.2 millimeters behind the edge. This thin profile is only possible because of the extreme hardness of our Damascus steel. Hand honing begins on a 1,000 grit stone. This step requires a human touch to refine the edge and remove any microscopic burrs left by the machines. The process is finished on a 3,000 grit stone. Each stroke is counted to ensure symmetrical sharpness, preparing the blade for its final visual transformation. The blade is submerged in ferric chloride. This acid bath is the reveal moment where the hidden beauty of the 120 layers finally emerges. A 4-minute soak is required. During this time, the acid reacts differently with the carbon and nickel steels, creating the high-contrast Damascus pattern we desire. As the minutes pass, the wavy patterns become darker and more defined. The nickel-rich layers resist the acid, while the high-carbon layers are etched more deeply. The blade is pulled from the acid and immediately rinsed. Stopping the chemical reaction at the perfect moment is essential for achieving the right level of contrast. A baking soda bath neutralizes any residual acid. This step ensures that the etching process stops completely and the blade won't corrode over time after it's finished. We gently wipe the surface to reveal the crisp, high-contrast pattern. The silver-gray nickel layers stand out brilliantly against the dark, etched carbon steel background. Now we fit the handle. We use stabilized wood that has been treated with resin under a vacuum, making it completely waterproof and resistant to warping. Holes are drilled through both the wood and the steel tang. Perfect alignment here is crucial, so the mosaic pins will fit snugly without any visible gaps. High-strength 2-part epoxy is applied to bond the wood to the steel. This creates a permanent, airtight seal that prevents moisture from ever reaching the tang. Decorative mosaic pins are tapped into place. These pins add a touch of artistic detail while providing mechanical strength to the handle assembly of the knife. The handle is shaped on a belt sander. The artisan works by feel, contouring the wood to create an ergonomic grip that feels natural in the hand. In the final inspection, we check the blade's alignment. Using a precision straight edge, we ensure the blade is perfectly true from the bolster to the tip. One last hardness test is performed. We must be certain that the final grinding and finishing steps didn't compromise the blade's exceptional 63.5 Rockwell hardness. The ultimate test is the edge. The blade glides through paper with zero resistance, a testament to the hours of careful forging, heat treating, and hand honing. Under magnification, the cut is perfectly clean. This level of sharpness ensures that the knife will perform effortlessly in a professional kitchen for years to come. We apply a light coating of food-safe camellia oil. This traditional Japanese method protects the high-carbon Damascus steel from humidity and fingerprints during its journey to you. The knife is wrapped in beautiful washi paper. We take as much pride in our presentation as we do in the technical manufacturing of our cutlery. Each knife is placed in its custom box along with a signed certificate of quality, detailing its specific batch number, hardness, and the date of production. With a 94% pass rate this month, these knives are ready to ship. From raw steel to a masterpiece, our process defines the peak of performance.